Hey guys, welcome back, and let's solve this Leetcode problem 1481, least number of unique integers after k removals. I'm doing this at Thursday, February 15th at 9:05, and this is today's Leetcode daily. So we're given an array of integers, array, and an integer k. We need to find the least number of unique integers after removing exactly k elements. So let's go straight to the examples. Here we have an array 5, 5, 4. We need to remove one element. If we remove the 4, only 5 is left. And so that is one unique element. So even though there's two 5s, obviously, there's only one unique element. So we return 1. What I'm going to do, and what you'll see me do in the code, is this is the same as the set of 5 and 5. If you've taken discrete mathematics recently, you know that sets are, by definition, distinct numbers or distinct items. So let's look at this example. Here we have an array 4, 3, 1, 1, 3, 3, 2, and we have k equals 3. We get an output of 2. We get this by removing the 4, removing the 2, and removing either the 1 or the 3. Let's remove a 1, and you see we're left with 3s and 1s, which is 2 unique elements. So we're going to want to solve this problem basically by removing a k amount of elements from the array and kind of, doing it in the most efficiently way possible, trying to maximize the number of unique, or trying to minimize the number of unique integers that are left after removing k amount of them. So let's think about what we did here to get to the number 2. We're given 3 things we can delete, right? So what if we deleted the 3s, because that's what they're the most of? Let's delete this 3, remove this 3, remove this 3. We're left with 4 1s and 2, which is 3 unique elements. So that was pretty much the opposite of what we want to do, right? So we want to do the opposite of that. We want to remove the elements that show up the least amount of times. So 4 and 2 are tied at showing up once each. 1s are in the middle with 2 showing up twice, and 3s show up 3 times. So let's start with what shows up the least. That's 4 and that's 2. At this point, we can remove one more element because we started with 3, we removed 2 already. And then it doesn't matter because no matter what we remove, there's going to be the same thing left. So let's remove this 1, and then you're left with 2 unique elements. So our goal is to remove k elements in the way possible that lets us have the least amount of unique integers left over. So we're going to want to know the frequencies of each element in the array, right? Frequencies. And what I'm going to do is store it in a dictionary, or a hash set, if you will. So let's go through this example again. We have a 4 that shows up 1 time. We have a 3 that shows up 3 times. We have a 1 that shows up twice. And we have a 2 that shows up once. So let's forget these keys and just focus on the values if we take these in an array on their own. And let's sort this array, right? So 1, 1, 2, 3. Now remember what this means. We have one element that shows up once, another element that shows up once. So we have one element that shows up twice. And then we have another separate element that shows up 3 times. And k equals 3 in this example. So these represent elements, right? Like if we're taking away this amount, if we're deleting these, this is how many we're going to have to delete to remove a unique element from the array. So obviously, let's think of this as like currency. We can spend all our currency deleting this. We can spend 3 to delete 3 elements, but we're left over with 3 other unique elements. So we'd be better off spending 1 to delete 1. Then we have 3 left over. Then we can delete this one. We can still delete one more thing, and at this point we only have 2 unique elements left over. So I think the big kind of mental leap there is realizing that you're subtracting from k the frequency of elements, and you want to do it by starting with the element that shows up the least amount of times. And then what you end up returning is the amount of unique elements you have after deleting everything. So let's go ahead and code it up. I'm going to start by just starting a variable distinct elements, and I'm going to use a set to just calculate this for me in one line. Sets, by definition, only contain distinct elements. So I'm going to want the length of the set of the array we're given. So this part of the code will get only unique elements, and then length will count how many there are. So by this example right now, we'll have 4 distinct elements. Then we're going to want to get frequencies. So like I told you guys in the drawing example, we're going to use a dictionary. Here we're going to have to loop through every num in the array, and this is common if you've seen me make frequencies before. We're going to want to make the num the key, and then use get to get whatever amount of frequencies there are at the key num. If the key doesn't exist yet, then we'll get 0 and then add 1 to it. So this get function just lets us not get an error for trying to access a key that doesn't exist in the dictionary. Okay, so now we know how many distinct elements we're starting with, and we know the frequencies of all the elements we're starting with. Now it's time to delete stuff. So let's loop through the list of values in the order from least to greatest, right? Like we did here. So remember, we want to access these values, and there's a way in Python that lets us do that. It's called the .values function for a dictionary. And we also want to sort it. So we can do that all in one line. And I'll show you what that looks like. So for value in frequencies, well, in sorted frequencies dot values. So here we want to check if the value is less than or equal to k. Because remember, what does value represent? It represents the number of times something is showing up in the array. So if it shows up more than k times, then we can't remove it because we're only allowed to remove k things. But if it shows up as many times as k or less than that, then we can completely wipe it out from the array and make our distinct elements 1 fewer. So if that is the case, subtract 1 from distinct elements, and then also subtract it from k, because we spent that many moves, if you want to think of it that way, deleting that many elements from the array. And then our for loop will automatically move us on to the next thing. I guess if it isn't passing, we can just immediately break instead of letting the for loop run itself out. Because since we sorted, these values are only going to get higher. And if it was already above k, then it's still going to be the case later on. And at this point, we can just return however many distinct elements we have left. So let's run it. It's accepted. Let's go ahead and submit. And it passed. And we get some Leetcoin for our troubles. So let's analyze the time complexity of what we just did. It might be better to think about this before, but let's be honest, it's easier to do it when the code's already spelled out. This line right here is O of n because of the set function. This line is O of n because we're looping through the entire thing to find the frequencies. This line is m log m because if you let m represent the length of frequencies, but in the worst case, we can just assume that it's n log n. And then the frequencies array itself is also going to be O of n space. So we end up with time complexity of big O of n log n and space of big O of n. So it's decently efficient. We get a little brownie point for using this breaking out of the else statement. And I hope that was helpful. See you in the next one.